All right, now we put the rubber disc in. That's the rubber disc, fits underneath there. And
I got it.
you got it? Cable. And the cable housing is going to be the first portion of the cabling that we'll work on. This is just a leftover piece. Otherwise, I'd measure approximately from the thumb of the terminal device back to the crossbar leather, and then I would cut it off. The first thing we'll connect is the retainer. The retainer slides into the base plate. So you'll notice that that's oblong, and this is oblong. We start off sliding it in, and it'll be hard to capture this on video, over the shoulder. So we put it in at an angle, force down the other side, and then rotate it. And then that locks that long axis that allowed you to pop it in and rotate it. So now that's locked in. But we don't want to have the cable jumping from the retainer all the way to the thumb of your terminal device, because the cable would be running along things, could get frayed and injured. So we'll migrate this down using our drill. And hopefully that kinking doesn't cause any problems. This is a lot more fun than having to turn it by hand. So what are we looking for when we're doing this? Well, how much range of motion or opening do you want in your terminal device? You want to be able to open all the way. We also want minimal interference between the cable housing and the terminal device. So we don't want to run it up so far that you're not able to open the hook all the way. And what's going to be coming out of the hook? You'll end up having your triple swivel coming out. So the gap between the cable housing and the triple swivel should be somewhere between 1/8 and 1/4 of an inch. So we'll go a little bit further and then we'll stop. And that's with the terminal device open up fully. Probably way too far. So if we put it here, we'd have interference, so I'll actually back that out a little bit. Gotta hold that open. And we'll just fine tune this by hand so that the gap between the cable housing and the triple swivel is approximately 1/4 of an inch, 1/8 to 1/4. So we should be good there. So now we don't have any interference in terms of maximally opening our terminal device. Next, we're going to put on the crossbar. We have the retainer. The housing is going to wrap around to the crossbar leather, which is going to hold the crossbar. And then we're going to want the cable housing to extend about 1/2 inch beyond the crossbar. So we'll just hold it here and we'll have him bend his elbow. And notice how it's getting a little bit tight and rubbing against the skin. We'll put a little bit more slack in there. Now have you straighten it out. So what we're looking for is we want to not obstruct any of his motion from fully flexed to extended. We also don't want this hanging out and catching on everything in the environment, from the handles on devices when you're walking through the lab to door handles or anything else that you can come into contact with. I'm not getting good suspension. Let's do it again. And straight. So I'm going to cut this a little bit shorter so that I don't have to thread that crossbar on as far. The crossbar, just like the retainer, threads onto the cable housing. If you hold the crossbar and you spin the cable housing, you're going to change the distance between the terminal device and the retainer. If you want to use a drill to do this, make sure you pop out the retainer so that the cable is able to move without twisting its position. We can check how loose this is or how tight it is by having the patient flex their elbow and extend. And like I said, we don't want extra gapping out, and we don't want it obstructing his elbow from flexing. So do that again. And straight. So we'll tighten it a little bit more. You have to pop it out so that you can move it down. Otherwise, you're just moving the distance between these two fixed points. Some patients will end up having the crossbar pop out of the leather crossbar assembly. So you separate them to put it in or take it out. If they have a problem with the leather opening up and it falling out accidentally, a lot of people will end up putting a tie wrap, a zip tie around it to help hold it shut. So, have you flex and extend again? Is it obstructing your motion? Is it dangling out, catching on everything? Did we accidentally, inadvertently change the position? Nope. So, our cable housing length has now been set where we want it. We'll turn around to the back and we can remove any excess. Usually this is done off the patient. And now we're ready to begin the cabling process. What we're going to do is, we know where we want the end of the cable to be. It's because of the cable housing. We can thread this through arbitrarily, and then it's going to come out the other end. So we need at least this long, but we also want supination and pronation in the hook. So we'll cut it a few inches longer, and this will just give us manageable size to work with. Otherwise you have 25 feet of cable to work with, and that can be a little bit cumbersome. So we'll get rid of our excess cable. The first thing that we're going to do with the cable is come over to the triple swivel. And we need to put a grommet, a rubber grommet, on the triple swivel to help hold it in the terminal device thumb. Otherwise it can fall out easily. So you have to fit that head over that hole, and the easiest way I've found is to place it on a hard surface and push your thumbnails into it to stretch it out over the head. Do, do, do. Like I said, sound effects. And then flip it the rest of the way over. Some people will put a little bit of soap on it to make it slide easily. It also makes your thumbs slide off easier, is what I found. So the next step is crimping that onto the cable. And a certain part of this channel is open and then it goes solid. So you need to know which area you can actually crimp onto. And if you want to know how long that distance is, you can push the cable all the way into that channel, place your thumb there for a marker, pull it out. This is how much room we have to crimp. Some places will have a pair of side cuts that they've either dulled intentionally or is dulled over the years and are rounded and don't come together and cut anymore. And they'll use that to crimp the cable in two different directions, one proximal and one distal in that barrel. The other system you can use is a crimping tool, where you place the device in the appropriate hole, place your cable in till it hits the bottom portion of it, its bottom out, and then tighten that crimping tool all the way down. And that's all there is to it. So that you end up with this crimp, or swage as some people say, and they'll use a swaging tool. Some of them you can put in vices and crimp the cable so that it connects. Other people I've seen will put a little drop of super glue on the end of the cable or inside the barrel and then force the cable in, so that when you get that crimping, it ends up causing all the wires to kind of splay and then that super glue ends up forming a plug and holds them out in that splayed position, so it's less likely to pull out. When we're looking at cable length, we want to make sure that the terminal device can open to the maximal position, which will be the shortest position between the thumb and the base plate and retainer. When you do that in the back, you'll end up with an excess of cable length. When it's retracted, it'll take up some of that cable length. Do you always want to work with your thumb up in that supinated position? No. So you may want to rotate the terminal device or pronate it, which ends up increasing the distance between the end of the cable housing and the thumb. And that's how we determine the length of the cable. So if I would have had the terminal device in the neutral position and crimped on the hanger, when I go to pronate the terminal device, it will end up stretching the cable, which will end up hitting on the cable housing and cause it to open when I pronate the device. We will cut this a little bit longer because we want a little gap between the cable housing and the hanger, and part of the cable is going to go into the barrel that's going to get swaged on the hanger. So, it's very difficult to crimp the hanger on in this position. We don't have much to work with, so that you have a few temptations that can happen. You can do it like the triple swivel, where you take it out of the housing, crimp it on, and then realize that we can't fit the hanger through the cable housing, which sounds obvious when someone points it out, but when you get excited and are working on this project, you might make that mistake. The other thing you can do is take either supinate the terminal device to create slack in the system so you have more coming out, or you can pop the triple swivel out of the thumb of the terminal device so that you can pull it right up against the end of the cable housing. So we'll feed that back through. We have a few inches coming out the back because this is what's taken up when you pronate the terminal device. I'm going to position this in my swaging tool. Put the cable all the way in and braid over one of the ends of the cable. And with that all the way seated in the back of it, I will crimp the crossbar on so that now when I put tension on it, I put tension on this end, it opens up the terminal device on the other end if I have it in the thumb. So we'll end up undoing the 4-bar buckle that goes to the control cable. Running it through the hanger, and you don't have to worry if the hanger's twisted because it's on a swivel, and we'll spin around. We'll have this going nice and flat, feeding back through the 4-bar buckle. Make sure that our harness is where we want it, towards the contralateral side, below C7. This is nice and snug, and we'll tighten this up to take some of the slack out of the system. And the reason we want to take slack out of the system is so that the patient doesn't have to do excessive range of motion to activate the terminal device. I'll lock this down. Otherwise, based on the number of rubber bands that he has on the terminal device, if it's not locked down, you can pull the control strap back through the 4-bar buckle. Now, theoretically, when Brian either biscapularly abducts or flexes his shoulder, it should transfer the force to the terminal device, causing it to open. And you'll quickly learn that you have a functional envelope, where it's difficult if you're working out towards your affected side, or if you're working too high, because you have to put tension on this strap on the back. And anytime you put tension on this strap, that cable housing will transfer the force to the other end. If it's too difficult to open the terminal device, then we might want to reduce the number of tension bands that you have on it. If your wrist unit is too loose in here, and you have too many bands to open it, what will happen is that when you activate the terminal device, if you have it in a pronated position, it will end up unpronating it and supinate it instead of activating the terminal device.